Hi guys, so today we continue our chapter 2 or topic 2, flow of water through soil for week number 7. As usual, we'll look at the program outcomes. We have PO1 and also PO number 2. Alright, this is our course outcomes. We have CO1, CO2, and then we have CO-PO mapping, CO1 to PO1, CO2 to PO2. Alright guys, now we go for the learning outcomes. At the end of the lecture, students should be able to first understand the seepage and 2D flow in isotropic and homogeneous soil and construction of flow nets. Number 2, understand the flow net construction rules for flow lines, equipotential lines, and boundary conditions. Seepage calculation using flow net under concrete dam, earth dam, and also sheet pile. Alright guys, now we go for the seepage and 2D dimensional flow. Flow of water through soil is called seepage. In many instances, the flow of water through soil is not in one direction only. The seepage taking place around dams, embankment, and sheet piling is two-dimensional. Vertical and horizontal velocity component vary from point to point within the cross section of the soil mass. Two-dimensional seepage problem was solved using a graphical method known as flownet. Alright guys, look at this. This is an example of dams. Okay, you look at the first dams and second dams. So what is the similarities of both them? This is an example of embankment. Look at this. And look at this. This is we call as embankment. This is an example of sheet pile. You can look at this both sheet pile. Right? You also may refer to the YouTube link here. Firstly, today we'll look at the condition. Okay, with an upward flow of water on downstream side, dangerous quicksand condition may occur with possible subsequent failure of the dam. Right, so quicksand is not type of sand, but it's a flow condition occurring within a cohesionless soil when its effective stress is reduced to zero due to upward flow of water. So it's happened to the cohesionless soil. For example of cohesionless soil is sand. Okay, the quicksand occur in nature when water is being forced upward under pressurized condition. In this case, the pressure of the escaping water exceeds the weight of the soil and the sand grains are forced apart. The result is that the soil has no capability to support the load. So the question is, does the quicksand occur in cohesive soil? No. Quicksand condition does not occur in clay. Alright. Alright guys, so in this chapter, we're talking about the quantity of seepage. So to determine the quantity of seepage, we have to use the flow net method. Alright, so we're using the flow net method. Flow net is a pictorial representation of the path taken by water in passing through a material. It is made of flow line and also equipotential line. So what is the flow line? What is the equipotential line? So flow line is a line along which a water particle will travel from upstream to the downstream side in the permeable soil medium. So from upstream to downstream in permeable soil medium. So this one is the flow line. Okay, see here, water travel here. This one is the flow line. This one is upstream. This one is downstream. Water travel from the upstream to the downstream. Okay, line along. Okay, so the line, so you have one line, you have two line, and then you have three line. Three and plus. All right, so that is the flow line. How about equipotential line? So equipotential line represent all points of equal pressure head. So since this one is to represent equal pressure head, so this one is perpendicular to the flow line. Okay. Alright, so you look at here, this one you have 90 degree. Okay, you have the 90 degree. Okay, you have the 90 degree. Okay, this one is about square. So this is flow line and equipotential line. So we have we have to draw the flow line and equipotential line from the soil. So we have the soil here. Right, so that's why if you see, even though that one is from upstream to the downstream, we not start here, we start from the soil because a quantity of seepage flow through the soil. Alright guys, this is example of flow net. Okay, so we have first one is for, this one is for sheet piles. Alright, so if you see here, this one is upstream, this one is upstream, this one is downstream. Alright, so as you know that the water flow from the upstream to the downstream. Alright, this one is the ground surface. Right, so that one is the ground surface. The so flow line, the water flow from the upstream to the downstream, so the water will flow here from the upstream to the downstream, so it's parallel. So you have to draw lines. So here, for example, you have 1, 2, 3, and about flow lines about 3.7. All right. So how about the equipotential line? So equipotential line here is, all right, if you see here, this one is 90 degree, 90 degree. So you have to draw the equipotential line. Okay, so for example here, 1, 2, 3, 4, 5, 6. 6 square. So equipotential line is 6. Alright. So another one is you have to know the H. H is the head from the upstream to the downstream. This one is H. Alright. So for example here, 20. Alright. Minus with 3. So H is about 17. So this example. Alright. That one first is for sheet pile. Okay, for example, another one is this one. The second example, this one is concrete dam. Concrete dam. Alright, so as usual, you look at this. You have the upstream, you have the downstream. And then this one is the ground surface. Alright, so water will flow from the upstream to the downstream. So, look at this. So you have to draw the flow line from the upstream to the downstream. Alright. Okay, look at this. This is parallel. Okay, this one is flow line. NF. NF. Right? NF. So we have 1, 2, 3, 3.5. Alright, so now we go for the equipotential line. Alright, this is equipotential line. You have to draw and you have to make sure that this one is 90 degree. This is about 90 degree and the size of the square should be square. Okay, you have to make sure this one is square. Alright, so for this one is ND is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So ND is 12. H is this one. Okay, this one is H, the height from the upstream to the downstream. So now we go for the assumption made for the this topic. Okay, the role of sheet pile is impervious. Okay, the role of sheet pile is impervious. The steady state flow of water from the upstream to the downstream side through the permeable layer is two-dimensional flow. Alright, the water is incompressible, and the last one is no volume change occur in the soil mass. Thus, the total rate of inflow should be equal to the total rate of outflow. Alright, now we go for the construction of flow net. How to construct the flow net? First is you have to draw the structure and soil mass to suitable scale. Alright, so you have to draw to the suitable scale. Second is identify impermeable and permeable boundaries. Okay, impermeable, something like rock, dense clay, dense sand, clay. Okay, for for example, sand. Okay, such a series of flow line, 4 or 5 lines, not more than 5 or 6. Sometimes it's 3 plus. Then sketch an appropriate number of equipotential line such that area bounded by equipotential line and flow line must be as near as square as possible. So means that it should be square fill. Okay, as square as possible, and the intersection of equipotential line and flow line must be at right angle 90 degrees. So means that, for example, here this one is alright, so this one is flow line. Alright, so the equipotential line should be right angle 90 degree. Right, it should be square and right angle. So for seepage calculation, okay, alright, look at this. The quantity of seepage can be determined using the following formula. So this is the formula. The formula for seepage calculation. Okay, so you have the Q is the seepage. So you have K is the permeability of soil. You may take from the laboratory, alright, and then or field test. Okay, if you remember, you determine the value of K. Then look at this, you have the H. H is the head difference between this upstream and downstream side. And then you have an F, and F is number of flow channel in flow net. So meaning that NF is number of flow line. And then you have ND. ND is number of equipotential line drop, or equipotential line, number of equipotential line. So this is the unit for seepage, meter cube per day per meter length. Alright, this one is the seepage calculation using the flow nets and the concrete dam, earth dam, and sheet pile. Alright, so for example is the combination of concrete dam and also sheet pile. So, okay, first is the step you have to know where is the impermeable layer and permeable layer. So this one is impervious layer, impermeable or impervious layer. So maybe this one is rock, for example. And then you have to know where is the upstream and downstream. So this one is upstream and this one is downstream. Upstream and downstream. So water will flow from upstream to the downstream. So next step is you have to draw the flow line. So flow line will start from here, right? The water will flow like this, flow line. All right, so water will flow alright. So if you draw the larger the size, so you have the lower value of NF and ND. Okay, for example, this one is flow line. So next is you have to draw the equipotential line. So you have the flow lines and equipotential line. So equipotential line, it should be something like this. This one is example. All right, so you have ND 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for example, ND is 11 and F is about 3. Okay, so H is, you have to determine H is 10. This is example. All right. Okay, this one is example or answer for the question. Okay, it depends on the your drawing. Okay, for example here, from the previous you have the K value. K is given. All right, so you have the H value, and then you have the, for example here you have the flow line 1, 2, 3, 3.3. For example, this one is NF, and ND you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12, and H is 10, K is 10 power of minus 3 over 1000. Okay, the Q value is this one. Okay, so to convert to meter cube per day, so you have to times with 60. This one is seconds for 2 minutes, 2 hour, 2 days. So you will get 0.24 meter cube per day. For example, this one is how this guy determine the value of NF and ND. From the previous one, I got ND is 3 and F is 11. So the answer quite be similar, plus minus, right? This is another example of concrete dam and sheet pile. Alright, so another example. So as usual, so you have to use the equation Q is KH and F over ND. Alright, so you have the value of K here. K H is 10 HF, and F and D you have to draw. Okay, so for example here, first you should know where is the upstream. Upstream is here, downstream is here, so means that the water will flow from the upstream to the downstream. So for example here, it will flow like this. See, this one is how the water flow from the upstream to the downstream. So you have to continue to draw, and then next is you have to draw another flow lines. Okay, you have to make sure that the flow lines is parallel. Okay, is parallel to one another. It's not cross one another. Okay, should be parallel. And then next is you have to draw the equipotential line. So just now I just draw simple. Alright, just simple. Alright, so this one is the flow line. So you have to draw the equipotential line. Okay, so I want to change the color. Okay, so it should be square. Alright, so you get the value, and F is 1, 2, 3. So NF3 and D is depend. Okay, it's depend on the your drawing. Okay, for example, ND here is 12. So you just insert all the value. So you have KH and F and also ND. Okay, this is very simple. For example, just now my drawing NF is 3 and D is 12. So it's depend on the drawing, but you have to make sure that you follow the rules. It should be square, and then it should be parallel, and it should be tangent to the equipotential line is tangent to the flow lines. So for example, my calculation is Q is equal to KH 2 times 10 minus 6 times 10 times 3 divided by 12. My answer is 5 times 10 power of 6, okay, meter cube per second per meter length. All right, that is my answer. So it depends on the your manual drawing. So and then you have to times with the 60 times 60 to convert to day meter cube per day per length. All right, so so you just follow the calculation and the drawing. So but the most important thing is you have to know the scale. You have to decide the scale. Okay, so means that when you want to draw the flow you want to draw the figure, so first is you have to know the scale. For example, 1 meter 1 cm is equal to 1 meter, 1 cm is equal to 5 meters. So it's depend because you have to draw the length of pipe, the length of a dam, and then the height. All right, so you have to refer to the scale. All right, now we go for the sheet pile. This is example of sheet pile. You have one sheet pile, so you have the upstream and then you have the downstream. So first is you have to know the value of upstream and downstream to determine the H. Okay, H delta H. Okay, it's not the head. All right, so second is you have to draw the flow line upstream to downstream. The flow line is here. Right, so you have the first flow line, okay, second flow line. So water flow from the upstream to the downstream. Okay, this is water flow. And then second is you have to draw the equipotential line. Okay, equipotential line, this one it should be 90 degree. Okay, all right, so this is example how to draw the equipotential line. This one should be 90 degree. Okay, for example, here you have to determine the NF and also ND. So you have NF is 1, 2, 3, and then you have another value here. This one it should be 3.7 for example, and then ND. Okay, you have 1, 2, 3, 4, 5, 6, 7, 8. So ND is 8. Right, so and then you have to calculate. Okay, for example, here they say that the NF is 4. For me is maybe it's 3.7, 3.8, okay, something like that. Okay, this is flow of water through soil for earth dam. This one is earth dam with the filter. Alright, so for the earth dam we have with filter and without filter. Okay, what you are going to do is you have to refer to the previous lecture how to draw and do the solution, how to sketch the flow nets and estimate the quantity of seepage. Alright guys. Study while others are sleeping, work while others are laughing, prepare while others are playing, dream while others are wishing. Good luck guys.